I mean, you might ask help from people, but it's motivated, it's self-motivated, it's autonomous learning essentially, and that you can learn really any topic, pretty much any topic. And that is the kind of AI that we're thinking about. And, that to me is what AGI is this basic system that can think, learn, and reason the way we do.
Hey everyone, and thanks for listening to and watching The Chief AI Officer. Today I'm speaking with Peter Voss, a pioneer in AI and a founder and CEO and chief scientist of Aigo.ai. Peter, thank you so much for joining me today.
Yeah, well, thank you for inviting me.
Yeah, I'm excited. We talked a little bit before the show. You have a very particular view on AI and how it should be deployed in the enterprise. So I think there's a lot we can get into. Before we get into some of that, can you give our audience a sense of when that first aha moment personally for you with AI was?
I think it was really when I realized that the whole field of AI had really lost its way. The original dream of AI, the term was coined 69 years ago, was to build thinking machines that can think, learn, and reason the way humans do. And they thought they could crack this in like a year or two. Of course, it turned out to be much, much harder. So what happened, the field of AI really turned into a field of narrow AI, which is very, very different because it's really the external intelligence. It's the intelligence of the programmer or the data scientist that actually solves the problem using a computer. It's not that you're building a computer or a software system that can actually figure out by itself how to solve these problems. So that was really kind of a breakthrough in realizing that we needed to go back to the original dream of AI. And in 2001, I got together with some of the people and we actually coined the term, three of us coined the term AGI, artificial general intelligence, to really, give a name to getting back to this original ideal. And we wrote a book on the topic in 2002.
Yeah, and so that topic of AGI, right, you hinted at it a little bit in terms of thinking, reasoning, understanding the other components of what a general intelligence would be. Can you talk a little bit more about that? How do you see that intelligence playing out versus the much more narrow version that we see today?
So, we didn't know that the term itself would sort of become quite well used and recognized, especially now in the last few years since ChatGPT, but there's a lot of confusion still about AGI. So now I start talking about real AGI, which is to have a system. Think of it like you have a smart high school student, and at that point you can really learn anything pretty much by yourself. I mean, you might ask help from people, but it's motivated, it's self-motivated, it's autonomous learning essentially, and that you can learn really any topic, pretty much any topic. And that is the kind of AI that we're thinking about. And, that to me is what AGI is this basic system that can think, learn, and reason the way we do. Now, of course, in many ways, it'll be much more competent than humans. And in other ways, it's going to be quite different. It doesn't have a biological body. It doesn't have this sort of reptile brain, driving a lot of what we do. But in terms of cognitive ability, it really is what makes human intelligence so special.
Yeah, I love that you've repeated that think, learn, and reason as some of the key components quite a few times, which I think says a lot about how you see that cognitive ability. I don't want to go too far down the route of AGI and what it means, because I could talk to you about it all day. It's so interesting. It's such an interesting topic. But I think our listeners and the people watching this are very interested in how to practically deploy AI in enterprises today, right? And I mean, you're close to this as well because you work on deployments. How would you summarize the current state of AI in the enterprise today?
Since generative AI has hit the scene big time in the last 18 months, really, obviously we see everybody scrambling to see how they can use this technology. I mean, when you first come across ChatGPT, it just blows your mind. I mean, nobody expected that just by scaling up, you could get such an amazing performance. It can write a poem in the style of Shakespeare or some rapper or whatever you want, and how it can summarize, and you can have a conversation, all of that. So that's really amazing. But I think what we're finding now is, as enterprise companies have spent a year on evaluating the technology and trying to implement it, they really find that they're hitting the wall against the sort of lack of reliability, lack of transparency, and the sheer cost of training these systems and operating them really limits to what they can do. So you really can't, for example, have them customer facing, anything that's non-trivial, because you always need to have a human in the loop to say, well, is it hallucinating? Is it doing the right thing? So I think people are starting to realize what those limitations are, and those limitations really are inherent in the technology, and we can talk more about it. It's not something that's going to go away. Hallucinations and the cost of operation, and the inability to learn interactively in real time. They simply can't absorb new information and integrate it into their model in real time. So there are a lot of opportunities for deploying them, but I think companies are starting to realize what they're not good for.
Yeah, I love that you hit on three things that we talk a lot about at Elemental Cognition as well, right? Which is reliability and transparency and ultimately efficiency, right? Because using a massive large language model to solve some of these, to try to brute force your way to solve some of these problems is very inefficient and has some of those issues in terms of transparency and reliability. Can you talk a little bit more about that? Is scaling infinitely going to be the answer? Or do you feel like you mentioned fundamental limitations to their design, right? Let's talk about that.
The original paper was attention is all you need. And now you get Sam Altman saying $7 trillion is all you need, to build new power stations and, to power this. That's kind of insane, because, our brain uses 20 watts to do what it does, not 20 gigawatts, so there's got to be a better approach. And obviously that is what I believe and what we're working on. So no, I think scaling, you're running out of data, training data. You can maybe have another 10x increase in the amount of training data, but then we're just completely out of training data. So it is going to hit a wall. And, like Jan LeCun recently said quite strongly, is LLMs are an off-ramp to AGI. They're a distraction. So, and I would agree with that. So finding the applications that it's good for, like summarization and translation and so on, as long as there's a human in the loop, is fine. But I think I think the limitations are going to become more apparent, and scaling up is simply not going to get us to the kind of intelligence that we need and the kind of robustness that we need.
Yeah, I agree. And I think in the enterprise in particular, right, what we're seeing is this use of LLMs for those types of use cases, as you mentioned, not customer facing, because you can't rely on it to not hallucinate or to kind of, there's retrieval augmented generation. There's lots of things that you can do to kind of ground it in your business. But ultimately, the way that it's doing its thinking or its speaking, so to speak, is inherently problematic. One thing that we're seeing a lot in the industry is so many misconceptions, right, on the part of executives who are embracing generative AI, who see this massive shift and this kind of tidal wave of AI coming at them, and they're trying to think about how to think about it, how to deploy it. What are some of the biggest misconceptions that you're seeing in the market in your conversations?
Yes, you're right. You talk about people putting external systems like RAG, and you're putting extra guardrails around the LLM, all sorts of different things. Trying to engineer the prompts dynamically and trying to tweak them, and so you're putting all these different guardrails around the LLM. When you end up having a reasonably reliable system, it's kind of the tail wagging the dog. Did you need the LLM in the first place to do what you're doing? And it's a problem because you have big consulting firms and of course companies selling LLMs like Microsoft selling their cloud services, hyping this, and well, it's in their self-interest. If you're a consulting company, Of course, you want to say, well, it can do all these magical things, but it's going to cost a lot of money, but we can help you implement it. So there isn't really a good counterforce because typical CEO of a company doesn't really have the knowledge or the understanding to say where it's appropriate or not. So they look at the experts, and the experts are still hyping this strongly. So I think that's the biggest thing to watch out for, is to really say, where do you actually need this technology? Where is it appropriate? And where can other technologies, where are other, maybe older technologies even, where are they're better suited?
Yeah, can you talk a little bit about that? What are the specific use cases? You mentioned summarization translation, so there are some that LLMs are good at. What are use cases that you are excited about in terms of enterprise AI deployment for these different architectures?
Well, I'm personally not that excited about LLMs, because what we are doing is we're helping enterprise customers to really have robust systems that you can rely on, and you can really replace human labor. And what we are focusing on is actually replacing call center agents, not just augmenting, so that you don't need to have a human in the loop. So one of our customers, for example, is 1-800-Flowers group of companies, Harry and David and so on. And there 2 months ago at Valentine's Day, we replaced 3,000 agents that they would normally have to hire for that massive spike that they have, at Valentine's Day. 90% of the conversations we handled were complete self-service. So people had zero wait time. The system has all of the information at its fingertips, so it can really, provide excellent service. So not only are you reducing cost, but you're also improving customer service. Now, trying to do something like that where you have multi-steps and each step has to be done accurately. If you try to do that with LLMs and, say you have a 95% accuracy, by the time you've taken 5 or 6 steps, you're down to 60% accuracy, which is, of course, totally unacceptable. So, that is the power of cognitive AI, where you have real-time reasoning, and where the system really can understand the conversation and has some level of metacognition, that it knows what it's talking about, as opposed to LLMs, which really are just blindly statistically producing, the next word. I mean, amazingly, but still, they're doing it blindly. They don't know what they don't know.
Right. I think that's the key. That's something we talk about a lot as well, right? When you have problems that require a long chain, a very precise reasoning, and every step in the chain is an opportunity for an LLM to drop the ball, you want to rely on other systems that are capable of complex reasoning, right? Formal systems, symbolic systems.
Right.
That reasoning is a very charged word these days, because I think what's happening is a lot of the providers out there are saying, their LLMs are passing reasoning benchmark tests. They're capable of this type of reasoning that feels like reasoning to many people. How do you deal with that? How do you deal with that misconception, and how do you address it when you're trying to bring things like Aigo to the market?
It's really hard. It's incredibly hard, because some of these benchmarks are very impressive, but we're now also starting to see reports coming through, for example, where the benchmarks on, I think, the legal benchmark or so, where it turns out, if you properly analyze it, it didn't do nearly as well on that. That was basically just pre-trained with the answers, with the questions and answers, essentially, which had enough information. So benchmarks are very, very, can be very misleading, because companies clearly work towards beating benchmarks,
right.
So, and once you try to move this into the real world, you get a very, very different picture. As you pointed out, if you have a multiple step process, you really can't afford to go, you have to have an extremely high accuracy, because at any point things can go wrong. And then, it's either you're doing something dramatic, like on the Chevrolet dealer, where they had a chatbot, a GPT chatbot, that ended up selling a truck for $1, and then the user said, well, are you sure this is a legal transaction? And the chatbot, yes, that's it's perfectly legal, So things like that. You really can't afford that. And, there's now the latest flavor is people talking about agentic or agentic, or I'm not sure how you pronounce it, systems. But you're not going to solve that problem. I mean, if an agent process has to do multiple steps, you still have the lack of reliability in every step. So I don't see how that's going to, just by sticking a different label on it, I don't see how the fundamental problems are going to be solved. But it is a real problem, when you're talking to customers, and they say, well, everybody's talking about large language models. Everybody's using them. There are billions of dollars going into it. So it must be something good. And absolutely, it is something good, but be careful of whether it's the right application.
Yeah, I think that's a key point that you made before about once you wrapped enough layers around the LLM, was that the best tool to use in the first place? And I think that combining these systems in hybrid, composite, however you want to term it, neurosymbolic architectures is going to be the way forward. The agentic route is an interesting one too, because I think there's lots of interesting things that will go on there. But ultimately, having the LLM be the reasoning brain behind what's actually tasking another LLM to do all of these things is always going to hit the fundamental limit that you're speaking about as well. And so, as organizations are trying to deploy technology like this, figuring out the best use cases, what are some of the biggest challenges you think they're facing right now?
Well, one of the big problems, apart from the things we've already spoken about, is knowing when an LLM is appropriate against the noise from consultants and companies selling the technology. I think that's inherently a big problem. Development cost, implementation cost is a huge problem. And the other big problem that we're seeing is how quickly the landscape is changing. And older models, basically, you might take a certain version of, ChatGPT 4 or 3 or whatever you're using, or Llama or whatever model you're using, and you tune your system, to the particular application that you want, and then that model becomes obsolete. That's another big problem. They're constantly changing, they're retraining models, and of course you don't want to use last year's model either. But they're constantly changing. There's also catastrophic forgetting as models are trained with additional information where they try to keep them up to date. It's a well-known problem in neural networks is that when you try to train them incrementally, basically without retraining the whole thing, you just try to train additional, fine-tune them or whatever, you can actually have it's very common to have catastrophic forgetting, meaning that some of the things that it knew before and could do before fairly accurately, it can no longer do, or it may no longer have that access to that information. So I think the fact that these models are changing all the time is a huge challenge to deal with.
So is it fair to say that should be a warning sign for any, a lot of enterprises right now are investing in these massive fine tuning of LLM projects. Everyone should have there's talk of every company will have its own fine tuned LLM in the future, but it sounds like in your eyes, that's maybe not the best path to go down.
Well, yeah, if you do, just be prepared to continue having the budget to continually retune. And then, do you have regression tests? Basically, do you have really good regression tests for that, so that you actually know when you get the latest model or you make some change, that what is breaking, or at least you have a chance of figuring that out.
Yeah, and in terms of looking towards deployment and kind of practical steps, right? What advice would you give to people that are trying to bring AI into their organization, that are at large companies where they're going to be serving huge amounts of stakeholders, so many different departments? How do you do that effectively?
Probably the best thing is to let somebody else who has a similar application, to see that somebody else has actually successfully done it, and not to be pioneering. I think a lot of CEOs and CTOs are afraid that they'll be left behind, but the technology isn't actually that much of a benefit, or putting it a different way, you don't have that much of a handicap if you're not on the bleeding edge of implementing these things. Now, the advantage of waiting to see how other companies, potential competitors or other companies that have similar problems, to see whether they can actually implement it. And again, with my experience in a call center, replacing call center agents, a lot of companies thought that with LLMs, they can replace call center agents. If you now look around, it isn't happening. It's simply not happening. So, if that's what you believe you can use for replacing call center agents, try and find a company that's actually doing it successfully, and you want beyond simple FAQs, of course, things like what's the nearest ATM, or kind of FAQ type things where people are still in the loop evaluating whether the answer makes sense or doesn't make sense. But you don't even need LLMs for that. I mean, technology has been around for a long time to do this sort of intent. Maybe LLMs are a little better at catching a broader range of natural language inputs to do them. That's fine, but it's not going to replace call center agents where you actually have to go through several steps, call APIs accurately, make decisions about, whether somebody should get a replacement or whatever it might be, what kind of product they want to buy and so on, and then having to update an API and doing all of those steps accurately. It's just not happening. So I think that approach should be generalized, I think, for companies to say, what I'm trying to do with LLMs, has somebody else actually done that successfully and, in a cost-effective way? And if the answer is yes, go for it. If the answer is no, you probably want to wait.
Yeah, that's a good advice and a word of warning for those that want to be so pioneering in this space. I actually spoke to Guillaume Laporte, who's Chief AI Officer at Foundever, who are a massive contact center company. I think 170,000 agents or employees. And he was very much saying a similar thing to you in the sense that what they're doing effectively right now is supplementing agents, right? He felt like there's always going to be a human in the loop for their systems. And they use LLMs where appropriate, but he didn't see it addressing the long tail that you kind of referred to, and also that more complex operation where you're plugging into different systems and you need to do that very reliably. It's going to be an interesting few years ahead, especially for those chief AI officers and similar titles that are leading the charge there. What advice would you give those people kind of personally who want to do this in their organization and who want to lead that? Other than obviously, you mentioned be wary and maybe don't be the first mover. But is there anything that you think they should do personally to kind of get up to speed on the market?
My life has been dedicated towards getting to real AI. And, like I mentioned earlier, Jan LeCun and Demis Hassabis has a similar assessment, the CEO of DeepMind, a Google AI company, that LLMs are not going to get us to AGI. And to me, is the focus, there should be much more focus on discussing how can we get to systems that are closer to 20 watts, that, that don't hallucinate, that are not black boxes that just do weird things, and that can learn interactively in real time. I wish more people were talking about that, and saying that's what we really want, and how can we get there? So, I'm just not that excited. I'm putting more energy into an off-ramp.
Yeah, that's a great way to put it. And how would you get there, right? I think elemental cognition, we have a particular view on neurosymbolic architectures, that combining neural net and formal symbolic systems to do reasoning, which is reliable. But how are you pursuing your dream at Aigo?
DARPA actually had, I think, a pretty useful categorization that they came up with a number of years ago, and they call it the 3 waves of AI. And what they mean by that, the first wave of AI is what we normally refer to as good old-fashioned AI. So those were basically, logic-based systems, expert systems, stuff we did in the 80s and 90s. Deep Blue would be a good example of that, IBM's world chess champion. To some extent, Watson as well, but Watson already is obviously going into what's now the second wave, which is basically neural network-based or statistical systems. And that's a wave we're riding right now, is the second wave of AI, which is all about big data, statistical systems. The big companies have a lot of data, they have a lot of computing power, So that's the hammer they've got. So they try to make everything look like a nail. The third wave, however, is cognitive AI. So its starting point is not, we have a lot of data, what can we do with it? The starting point of cognitive AI is, what does real intelligence, human-like intelligence, what does that require? So it starts off with understanding intelligence and then building a system that implements it and that actually makes, creates the abilities that are necessary for human level cognition. So just to give a few examples, one of them that I mentioned already is the ability to learn interactively in real time. Like a child, you can show it a picture of a giraffe once, and it can recognize, if it's never seen a giraffe before, it can now recognize a giraffe in different colors, upside down, different sizes, and so on. It doesn't need thousands or hundreds or thousands of examples of a giraffe to learn that, and can learn it instantaneously. You don't need to go through another batch process. So being able to learn in real time interactively and to integrate that knowledge into your existing knowledge, to be able to generalize it, to abstract, to form abstractions, to form hypotheses on information as it comes in. So that is a key requirement of human-like intelligence. Another one is metacognition, to basically the ability to think about thinking, to know what you're thinking about. Which, that. So those are just two examples of what is really required for human level intelligence that doesn't require, gigawatts of power and 10 trillion pieces of information to be trained on. This is the exciting part, the third wave of AI, or cognitive AI.
Yeah, I think that is a very exciting idea that gets us much closer to, as you said, that concept of AI that we all think about, that so many science fiction writers have written about, that is like true intelligence. And what, as an end note, to come back to the application within business, how transformative would something like that be in your mind? How would an enterprise actually go about deploying something like that, and what are the implications of it?
Well, at the moment, the state of technology in AI is that there's a lot of human labor involved. We still have this that I started talking about, is that it's really external intelligence that solves problems.
Mm-hmm.
That's true for LLMs as well, because what you train it with, how you fine tune it, what RAG, if you add a RAG to it, or prompt engineering, all of those things, it's really the human intelligence that ultimately makes things work. Now, the current state of development in cognitive AI that we have, and I think Elemental is also much closer to kind of a cognitive AI approach, is that there's still very much a human in the loop in setting up ontologies and understanding the customer's requirements and so on. So it's still quite human intensive to actually get applications to work well, even with cognitive AI. Now, the future of development in cognitive AI, once we get close to AGI, to artificial general intelligence, it'll be a complete game changer, because then the system will be smart enough that it can configure itself. It's as if it's then, not as if, it can essentially sit down with a customer and say, all right, I need to see your API documentation of what we want to integrate with. I need your business rules. I need to talk to your call center people to see how they give service. And by having that interaction, it'll be able to essentially, call it, configure itself. It will be able to teach itself. It'll learn to do that job, and pretty much any job. It'll be massively transformative.
Yeah, I think that's a very exciting future. There's a lot of things that you said there that actually overlap very much with how we're approaching things at Elemental Cognition. So it's nice to see someone else on that journey as well. Peter, I could spend all day talking to you on AGI, on enterprise AI, on all of these things, but that's all we have time for today. Before we wrap up, where should our listeners go to get in touch with you or to follow your work?
Yeah, it's fairly easy to find me. I'm on LinkedIn, Peter Voss, Twitter, and of course a website. And I have a lot of articles that I've written about, everything from philosophy, free will, what is morality, to, of course, cognitive AI, limits of large language models, and so on. And anybody in Austin, I have a monthly meetup here, AGI Beyond LLMs as well.
Well, that's great. Yeah, I can attest to the articles. I read some before the interview. And if you like to think seriously on AI and want to understand beyond LLMs, what are the possibilities, I'd say absolutely go check out the work of Peter Voss. Peter, thank you so much for joining the show today.